Hello, you are welcome to Excellent Touch Tutorials, and this is Sir Isaac. In my previous video, I covered an aspect of measurement of physical quantities, which is the aim of the lesson and the learning goals. In case you have not watched it, use the link provided to access it and to watch it. In this video, I'll be sharing on the definition of physical quantities and measurements in continuation of the previous video on measurement of physical quantities. Now let's get started. Previously, we said that physics is the study of matter and energy. So it means that the study of physics concentrates so much on matter or centered around matter. Therefore, every matter has a physical quantity. And apart from the fact that every matter has a physical, remember when we say matter is anything that has mass and occupies space. So anything that has mass, you can weigh it and then can occupy a space is called matter. And from that definition of matter, you would agree with me that matter is almost everything that you can see around it, including yourself. You are a matter, okay? So even air is matter. What, even though you cannot see, but you can feel it, and it has mass and occupies space, is also matter. All right. So every matter, which is literally now everything you can notice around you, has physical quantities. Apart from the fact that they have physical quantities, they are also affected by physical quantities. So it is important to understand what this physical quantity really is. So what is physical quantity? Physical quantity is the physical property of matter that can be quantified, can be sized, can be valued, and can be measured. For example, length, which is the gap between two positions. Mass, which is how heavy something is or how light something is. Time, which is the space between events, the duration of event or intervals between events. Then speed, how fast or slow something is moving. These are all physical quantities because they affect matter and they can be used to rate matter. Now that we understand what physical quantities are, what then is measurement? Measurement is the process of assigning a numerical value to a physical quantity by comparing the physical quantity to a standard unit or reference. That is, in measurement, two things are very, very important. Assigning a numerical value to the quantity being measured, and then you are assigning that numerical value to that quantity by comparing that quantity with another quantity you are considering to be standard. So it means measurement cannot occur if there is no standard. There must be a standard for measurement to actually take place, especially accurate measurement, reliable measurement, precise measurement. So measurement, once again, is the process of assigning a numerical value to a physical quantity by comparing that quantity to a standard unit or reference. And any device that is used in carrying out measurement is called a measuring instrument. We have a lot of them. We are going to look at them later on. What are the two criteria that can make a measurement to be standard? Number one, the measurement must have magnitude, must have size. And that magnitude or size, you use a numerical value for it. So that numerical value tells you about the magnitude or tells you about the size. So a standard measurement, number one, must have magnitude. For instance, we can say that, okay, after measuring, let's say there is a boy here at this position, and there is a house here at this position. And then we are asked to find the distance between this house and this boy. What is the gap between the boy and the house? Now, for us to know what the size is, we take a measuring instrument and measure it. Now, if the distance between the boy and the house is actually, let's say 15 from our ruler, we write it 15. This 15 now tells us the size of the measurement or the magnitude of the measurement. That is not enough to make measurement standard. So the next criteria that makes measurement standard is assigning a unit to the magnitude or to the measured value. Okay, this is the point. All right, so from here we discovered that the distance between the boy and the house is actually 15. All right, this 15 is the distance We can only know that it's distance because there is a grammatical illustration of this. Alright, so what if I write 15 somewhere? How will you know that this 15 is actually talking about either the length between a boy and a house or even the mass of somebody? You cannot tell. So there must be a unit that tells you what physical quantity was actually measured in this case. So in this case, we know that length is measured in meters or in centimeters. So if the distance between the boy and the house is actually in meters, we can say it's 15 meters. So anybody that gets to see this will know that what we measured here is actually length, not mass, not temperature, and not current. What we measured here is actually length or distance or height, because they are all examples of length. So please take note of this. So two things make measurement standard. First is the magnitude, and second is the unit. So at this point, it is very clear, and we can state categorically that every physical quantity has a unit of measurement for proper identification. Like I said earlier, there is no way to tell the physical quantity whose size is 15 since the unit is not defined. But we can tell if 50 kg is the mass of something because of the identifiable unit, which is kg, meaning kilogram. So we can tell 120 centimeter is the length of something. Why? Because of the unit attached, which is cm, meaning centimeters. So two criteria, one more time, make measurement standard: the magnitude, the numerical value, or the unit, which is the symbol representing the physical quantities being measured. Now, a standard of measurement should have the following qualities. Please, very important, take note of the following qualities of a standard of measurement. Anything that is used as a standard or as a reference point for taking measurement, these are the qualities that it should have. Number one, it should be unambiguously definable, meaning it should have a clear, precise, and unique definition that should leave no room for misinterpretation. For example, the meter is defined as the distance traveled by light in vacuum during a specific time interval. So there is no ambiguity, no two meanings to it. If the measurement is unambiguously definable, it means that the measurement will always be consistent, it will always be accurate, it will be repeatable, and it will be comparable. So one thing ambiguous definition does is that it would always lead to error, so that somebody will use it to take measurement here, it will give the person a particular value, and then another person will use the same thing to take measurement another place, and it will be giving the person a different value entirely. It means that that particular standard of measurement or measuring instrument is actually ambiguously definable. That means you have several meanings, or it takes different readings of the same thing. All right, so a standard of measurement should be unambiguously definable, because that ensures consistency, it ensures accuracy, it ensures repeatability, and ensures comparability. The second quality of a standard of measurement is that it should be easily reproducible. A standard of measurement should be easily reproducible, meaning that it should be possible to recreate or duplicate the standard with minimal effort or resources while maintaining its accuracy and precision. It should be easily reproducible. And number three, it should not vary with time and place. It should not vary with time and place. So anywhere it is used to take measurement, the measurement should remain the same, irrespective of whether it's today or tomorrow, or whether it's here or there. It should always give the same result. And number four, a standard of measurement should have the possibility of being scaled. It should have the possibility of being scaled simply means that it should be multipliable, it should be divisible, it should be convertible for the purpose of flexibility, practicality, and universality. For example, second, which is the standard of time, can be scaled to hours, so that if a measurement is taken in seconds and you have 3,600 seconds, you can say that is just 1 hour. That means you have been able to convert it from seconds to hour. And so in that case, we can also say by scaling 7,200 seconds, therefore we make 2 hours, since it is just the double of 3,600 seconds. Alright, so that's what scaling is all about. So a measured value should be scalable, it should be convertible, and it should be divisible or multipliable. Why is it necessary? This is necessary because a measured value that cannot be scaled will be limited, will be inconvenient, and will be restrictive. So at this point, let's have our test of knowledge. It's quiz time, so put on your thinking cap and answer the following questions. Number 1, what are physical quantities? And number 2, define measurement. Number 3, mention 3 qualities of a standard measurement. Do leave your answers in the comment, and here is your assignment. Why is measurement important? Please, if you like this video, be sure to click the like button, subscribe, and leave a comment. In my next video, I'll be sharing with you things that will make you understand physical quantities better. Physical quantities are grouped into 2 types based on their definition and relationship with other physical quantities. So in my next video, I'll be sharing with you the types of physical quantities.